Hello, guys. This is your review for your midterm. So all of this is multiple choice except for 16 and 17 at the end. And you can see they have parts to them, so you'll be able to tell. And it is all non-calculators. You won't need a calculator for anything. So draw a graph with a removable discontinuity. That just means a hole. A non-removable would be a break, which we call a jump discontinuity, or an asymptote. All right, find P so that the graph is continuous at -1. That means that you want to set the two pieces equal. You want them to link up. So we're going to set this equal to just P, which is convenient because find P. And also these x plus 1s are going to cancel, which is also convenient. So we're going to set x minus 2 over x plus 7 equal to P. And it says at x equals -1, which you can also see here. So we're just going to plug in -1. So that's going to give us -3 over 6, which is -1/2. So -1/2 is our answer. All right, limit as x goes to 3. As a heads up, if you plug in 3, you're going to get 0 over 0. So there's two ways you can actually do this. One would be algebraic. You can factor it, cancel out, and then go ahead and plug in 3. Or you can do L'Hopital's rule, which would be to take the derivatives. In this case, I think that's going to be a little bit easier. Derivative of the numerator would be 2x minus 2, denominator 2x minus 8, and then we're going to plug 3 in. So that'll be 6 minus 2, which would be 4. This would be 6 minus 8, -2. So -2 is our answer. All right, average rate of change is just a slope. We're going to get our 2 points. We need to plug in 1 and we need to plug in 2. So if we plug in 1 to this, we're going to get 3 minus 2, which is 1. If we plug in 2, 2 cubed is 8, times 3 is 24, minus 4, which would be 20. So when you set up your slope, it's going to look like this. If it's free response, you can stop there, but this will be multiple choice, so you have to keep going. So that'd be 19 over 1, which is just 19, because they're not going to have this as an answer choice, when it's multiple choice. So use the graph to find the derivative at -2. So here's your point -2. Derivative means slope of the tangent line, slope of the tangent line. So really all this is asking you for is the slope of this line here. So let me find another pretty point. We can just count the little boxes. Regular old algebra 1 slope, it's going up 2 over 1. So 2 is the answer to that. So you're just knowing what this notation means and understanding that it means slope. This you do not want to do as a limit. You want to do it as a derivative. So you're going to figure out what the function is. That's just following the pattern. Take the derivative and then plug in whatever number it is that they're asking you for. And just as a hint, it's not 0. 0 is just part of the pattern. So your pattern is 2x cubed. This is that f of x plus h minus f of x over h formula. So, don't overthink it. It's just 2 something cubed. That derivative would be 6x squared, and the number we're plugging in is 5. So 5 squared is 25, times 6 would be 150. All right, instantaneous rate of change just means derivative. So we're going to find the derivative, and then we're going to plug in -2. So derivative is 3x squared minus 10x plus 7. Just going to plug in -2. So that would be what, 12 plus 20 plus 7. So what is that, 39? Kind of add that up in my head real quick. So this one is asking you for an equation. That means you need a point and a slope. So off to the side here, I'm going to write my point is -1 something, and then I'm looking for my slope. So the point, you're just going to plug in -1. So let's see, that would be -4 plus 3. That would be -1. Cubed would be -1. Let me just write that down. And then -1 minus 2 would be -3. So multiplying those, you just get 3. Slope comes from the derivative. So we're going to find our derivative, and then we're going to plug in -1. And that is going to give us our slope. Now, this involves a product rule and a chain rule. So product rule is the first thing, which is this 4x plus 3 cubed. So first thing times derivative of the second, which would actually just be 1, which I'll go ahead and put, but you don't need to. Plus the second thing is that x minus 2. And then it's derivative of the first. This is where the chain rule comes in. You're going to bring down the 3. It'll drop to a 2. The guts of it stays the same, and then you chain on the derivative of that inside stuff, which is 4. And now we're going to plug in -1 to all that. So this would be -4 plus 3. That's -1 squared would just be 1. So this entire thing just ends up being 1. Plus, I'm probably going to need to write a little bit of this out. I can't do all of that in my head. -1 minus 2 would be -3. Times 3 would be -9. This would give you -1 squared. Actually, conveniently, that'll just be 1 times 4 would be 4. So this is 1 minus 36, so -35. And I actually just realized I did a copy error. So that is almost the right answer. When I copied down the first thing, it's not squared, it's cubed. I just looked over at my answer key to make sure I did it right. And I was like, that's off by a little bit. So this will actually be a -1 because you end up with -1 cubed would be -1. So -1 minus 36 would be -37. If something like that happens to you, actually, I don't get upset when mistakes like that happen because then I can show you how to fix them. You don't give up, you just go back and fix it. It's going to be multiple choice. So likely that answer wouldn't be one of the choices, and then you'd be able to go back and fix it. And so I'm just writing out the equation here. All right, find the derivative. This is a chain rule. You're going to bring down the 5. It's going to drop to a 4. And then you chain on the derivative of tangent, which is secant squared. And that is all there is to that one. Right here, we are given position. When is the particle at rest? That is when velocity equals 0. So we're going to get our velocity. That would be 4t minus 8. Set it equal to 0. And then solve that. You're going to get t equals 2. This one also gives us position. What is the acceleration when the particle is at rest? So first we need to find when the particle is at rest. That's the same thing we did in number 10. We're going to get our velocity, set it equal to 0. So that'll be 8t cubed minus 24t squared. We're going to set that equal to 0. We can factor out 8t squared. That'll leave you with t minus 3. So you get 0 and you get 3. 0 we're not going to use in this. I think I didn't print it on here, but like on the test, it's going to say times bigger than 0. So we're not going to use t equals 0. We're just going to use this one. So we get times 3 for this. So we want to find the acceleration at time 3. So I'm going to find acceleration, and then I'm going to plug in 3. So we're just going to do the derivative of velocity. That'll be 24t squared minus 48t. And we're going to plug 3 into that. So 3 squared is 9. 24 times 9. I'm going to just do a little margin problem, or you could figure that out in your head. What is that? 216. And then 48 times 3, same thing. I'm just going to do a little problem off to the side. Or if you're one of those people that can like do that in your head, that's cool. 144. And then when you subtract those, I'm just going to write that right here. What is that? 72. Sometimes you have to do that. They give you non-calculator problems where you have to do, a 2-digit number times a 1-digit number. And that's, that at this level, that's valid. You sometimes have to do that and work out the math on your own. All right, this is our related rate problem. A cylinder is being stretched. Height is increasing at 3 inches per second. So that's dh dt. I'm not going to worry about units because, again, this is going to be multiple choice on your test, and the units will be printed on there for you. Positive because it says increasing. Volume is increasing. So this is dv dt is 60 pi. Oh, that should be inches cubed per second. My bad. It's a volume, so it should be cubic inches. What is the rate of change of the surface area? So ds dt is our question mark. It should turn out positive because this is all increasing. When the radius is 4 inches. So when r is 4. And we're given our formulas for volume and surface area. So since we have the rate of change of the volume, let's start with that one. We are going to need them both, but let's start with this one. We're going to do dv dt. And this is a product rule. Pi r squared is the first thing, h is the second thing. So first times derivative of the second plus second times derivative of the first would be 2 pi r dr dt. Now we're going to plug into that and just kind of see where it takes us. Sometimes you have to take what they gave you and just play around with it until you can get to, your question mark value. So this dv dt is 60 pi. I'm glad that there's a pi in there because I have a feeling some of these pi's might cancel out, or, we'll see what happens. Pi r squared dh dt. Let me see, we have r squared, that would be 16 pi. We have dh dt, that's 3, cool. All right, we do not have the height, but we do have the radius. So actually, I'm gonna rearrange this a little bit. I'm gonna write the 2 pi for, actually, what is r? R is 4, so that would be, let's see, 8 pi. I don't have h, and I also don't have dr dt, so we're actually missing, quite a lot here. All right, so this is going to be 60 pi equals 48 pi plus all of this. And then I'm going to subtract the 48 pi over. So that's going to be, what is that, 12 pi equals all of this. And I'm not really sure where I'm at with that, so I'm going to switch over to the other function and take that derivative. And again, sometimes you just have to play around with it until you get where you're going. All right, this is also going to be a product rule. So 2 pi r is the first thing, h is the second thing. So definitely run out of room. Let me see if I can move this over a little bit. Let's draw a line in the sand here. All right, so first is 2 pi r, derivative of the second plus the second, and then derivative of the first would be 2 pi dr dt. And actually, I think I see where we're going here because I have pi h dr dt over here. So I think we're going to do a little bit of substituting here. So let's see, ds dt, which is the thing that we're trying to find, r is 4 and dh dt is 3. So 4 times 3 would be 12, times 2 would be 24. So we've got 24 pi plus, and then let me see what I can do with this. I've got 2 pi. Let me see if I can turn this into a 2 because it's practically the same thing. If I divide these both by 4, 2 pi h dr dt. So 2 pi h dr dt. So all of this equals 3 pi. So in for all of that, I'm going to put 3 pi. Phew, that was hard. All right, and so that is 27 pi. And again, I'm not worrying about the units because it's going to be multiple choice, so it's going to be printed on there. That is an example of one where you kind of just have to take what they gave you and play around with it until you get where you're going. But that is a lot for a multiple choice question. But I found it on AP Classroom, so, fair game. 13, mean value theorem. So we need a slope. So I'm going to plug in 1 and 4, get my slope, and then set that equal to the derivative. So if we plug in 1, it's going to be -5. If we plug in 4, let's see, that'll be 64 minus 24, so 40. So when we do our slope, it'll look like this. That's 45 over 3, which is 15. And I'm going to set that equal to the derivative, which would be 3x squared minus 6. So we're going to add over the 6. That'll be, what is that, 21 equals 3x squared. 7 equals x squared. Now you square a root, you would get plus and minus, but it needs to be on this interval. So we only get the positive square root of stuff. Right, absolute maximums and minimums, that is your candidates test. Your candidates are endpoints and critical points. So I know -2 and 0 are going to go on here. I need to get my critical points. So that is derivative equals 0. That'll be 12x squared minus 18x minus 12. Those will all divide by 6. And then we're going to split this. So it'll be 2x and 1x. Let me see. 2 will be 1 and 2. We want a -4, positive 1. This is going to give us -1/2 and positive 2. I only need to use the -1/2 in this case because positive 2 is going to be off the interval. So you plug all of these into the original function, and we're going to have to battle through this because it's non-calculator. Sometimes that happens. All right, if you plug in 0, though, that's just going to be 3. I'll do that one first because that's the easiest one. Plugging in -2. All right, here we go. -2 cubed is -8 times 4 is -32. This will be 4 times -9. That's -36 plus 24 plus 3. I like to group the positives and the negatives. So this will be -68 plus 27. So that is going to be -41. All right, and then plugging in -1/2, I'm gonna have to work that down here because I ran out of space at the top. -1/2 cubed, that'd be -1/8 times 4b, -4/8, which would be -1/2. -1/2 squared would be 1/4, so this will be -9/4. -1/2 times -12, that'll be +6, and then +3. So my common denominator is going to be fourths. This will be -2/4 minus 9/4. Let me put these together. Total, that would be 9. So that would be 36/4. So let's see. -11 plus 36 would be 15/4. Oh, no, wait, 25/4. And we are asked for the absolute maximum. So it's not going to be this one. Let's see. 24 divided by 4 would be 6. So 25/4 is going to be slightly bigger than 6. So this is the biggest one. Now, sometimes they ask you for the maximum. Sometimes they ask you for its location. In this case, the maximum is 25/4. I can guarantee -1/2 would be one of the other choices. If they asked where is it located, it would be the x value, but the maximum is this output value, so 25/4. All right, concavity is second derivative. So we're going to get our first derivative, we're going to get our second derivative, and then we're going to make a number line. So first derivative, that would be 6x squared minus 16x. Just keep on going. That'll be 12x minus 16. If we set that equal to 0, we are going to get 16/12. What is that, 4/3? So if you make your number line with your 4/3, nothing is weird or backwards here. So we're going to be negative, turn positive. They asked for concave down. That's where your second derivative is negative. So -infinity to 4/3. All right. Oh, that's the end of the multiple choice. Now we're on to the free response. Find the x coordinate of critical point. They give you f of x, they give you f prime of x. That's nice. You don't have to do any derivatives. Critical point is derivative equals 0 or is undefined. So we're going to set the numerator equal to 0. And we're going to set the denominator equal to 0 as well. And here's the kind of good thing. This one just gives you 0, but our domain does not include 0. We just want greater than 0. So that one doesn't count. So we just kind of toss that out. This one we're going to solve. So you're going to add over the 4. To cancel out ln, you do e. So your answer is e to the 4th. That's a pre-calc thing. I'm sorry you're expected to remember that. But e and ln are inverses. So you exponentiate to cancel them out. And remember, this is a number. E is about 2.7. So 2.7 to the 4th, it's just a value, is all that is. So we did that first part. Find the x coordinate of the critical point. Determine if that is the location of, because this is not the relative maximum or minimum, just the location of it. This is going to involve a number line. So I'm going to take my -4 plus ln of x and make myself a number line. I'm starting this at 0 because we want 0 or above. Now, I don't know exactly what e to the 4th is, but I know 1 is in between here. And 1 is the number that you want to put in because we can do ln of 1 without a calculator. ln of 1 is 0, and that's something that you kind of just need to know. Again, that's from pre-calc. So if you plug in 1, you're just going to get -4. So this is going to be negative and turn positive, which means that we end up with a minimum. Negative to positive is a minimum. Justify means you need that sentence. It should start f of x is or f of x has. So f of x has a relative minimum at x equals e to the 4th because derivative, that's your source, changes from negative to positive there, or at that value. All right, inflection points, we don't have to justify, just find them. Inflection points is second derivative equals 0. So we actually have to do that. They didn't give us the second derivative. So we're going to do the derivative of this. That is a quotient rule. So it is denominator derivative of the numerator, derivative of negative 4 is gone, derivative of ln is 1 over x, minus the numerator, derivative of the denominator over denominator squared. Now, again, I'm not really going to use this part. That's going to give you x equals 0, which again is not part of our domain. So we're really just looking at the numerator. Here, one of the x's cancels, so you just get x. I'm going to distribute not a 2x, but a negative 2x through these parentheses. So if I distribute a negative 2x in there, that's going to be plus 8x minus 2x ln of x. We're setting that equal to 0. This will combine to be 9x. And then the best we can kind of do there is factor. All they really have in common is x. So we're going to factor out an x. Again, that's going to give you x equals 0, which is not part of the domain, which is nice because you keep on getting to toss it out. Like we don't need that part. So we're just going to set this equal to 0. I would subtract the 9 over, divide by negative 2. Negatives are going to cancel. And then again, same thing that we did up here. To get rid of the ln, you do e. So it's e to the 9/2. And you didn't have to justify. So that's just the answer, which is cool. I don't want to do any more work. All right. And then this one's a limit as 0, going to 0 from the right of f of x, which I'm going to copy down is this 3 minus ln of x over x. So basically, we're just seeing if this comes out positive or negative. ln has an asymptote. If you need a graph of ln, it looks like this. Again, it's that sideways swoop. Kind of just need to know that one. That's why ln of 1 equals 0. This is your 0.10. So it's either going up or going down. We're just going to kind of test our signs. So if you go to 0 from the right for ln, you get negative infinity, but there is a negative there. So that actually turns out positive. And if you go to 0 from the right of just x, well, if you pick a number to the right of 0, 1, 2, 3, anything, they're all going to be positive. So this comes out to positive infinity. If you got a negative in there somehow, it would be negative infinity. Like, for example, if this was a plus instead, as you go to ln from the right, it would be negative infinity. Then you would get a negative there. Then it would be negative infinity. So you got like a 50-50 shot on that one. All right, last one. We are given f twice different. They would say twice differentiable a lot. They say that a lot just to say like there aren't any problems. There aren't any holes, breaks, asymptotes, sharp edges. Basically, they say this to just say everything's good. You can do the problem. You don't need it really for anything here. All right, so let f be twice differentiable function defined -0.5 to 4.5. F of 1 equals 5. I like writing those as a point. So I'm going to write 1, 5. The graph of f prime, the derivative of f is shown. So this is f prime. Are they going to ask you questions about f prime? No. In fact, they're not even going to ask you questions about f. They're going to ask you questions about g. G is this, which I'm going to write again just to make sure I see that really bold here, because I guarantee that's the one that they're going to be asking us about. But remember, they're not going to give you an undoable problem. So they're going to have given you enough information either with this point or this graph to do the problem. It's not going to be undoable, right? Write an equation. That means you need a point and a slope. Equation tangent to g at 1. So we're going to plug 1 into function g. So if I plug 1 in here, I'm going to have 2 e to the power f of 1. They gave us f of 1. It is 5. So it's going to be 2e to the 5th. So let me recap that again. When you plug in 1 here to function g, f of 1, they told us is 5. So it's 2e to the 5th. I actually kind of like questions like that because you don't have to do anything. They gave you all the numbers that you need. Slope comes from derivative, so we're going to have to find g prime. This is going to be a chain rule. It's 2e to the f of x. And then you chain on the derivative of f of x, which is just f prime. Don't overthink that. And then we're going to plug in 1. So we already did this part. F of 1 was 5. So this is 2e to the 5th. And then f prime of 1. They have to have told that to us or given us the ability to find it. And they gave us this graph. F prime of 1 is 3. And when you multiply those together, 2 times 3 is 6, so 6e to the fifth. And then you just take that and write your equation. I realize it looks funny, but again, remember e is a number, so these are all just values. I just don't know what they are without a calculator, some kind of decimal. All right, part B, on this interval, find all values of x where g has a local or relative minimum. Justify your answer. That's going to be our sentence. All right, so we're going to look at our derivative, which we already found. I'm just going to write it again. So we're going to take our derivative, this 2e to the f of x, and then chain on f prime of x. We're going to set that equal to 0 to get our critical points. Now, if you set this equal to 0, you're not going to get a result. Even ignoring f of x, like pretend it's just 2e to the x. E is a swoop. It's going to do something like this. It is never going to touch 0. Hey, what if your exponent is negative? Well, it's just going to be going down instead of up. The point is it's never going to equal 0. So this part we can ignore this. It's not going to give us a result, which is good. You get to kind of ignore that. So we're really just looking where f prime equals 0, and this is our graph of f prime. Our critical points are 0 and 4, so those are our 2 critical points. And we're looking for the one that is the location of a local or relative minimum. That means a change negative to positive. So where we have below sea level to above sea level is 0. So we're going to write, and this is a little tricky because I have coached you to write f of x is or f of x has. Don't get hung up on the letter of the alphabet because this one's G. And if you write F, they'll mark it wrong because there is an f of x in this problem and it's something else. So just be really, really, really careful. So G of x has a relative minimum at x equals 0 because G prime changes from negative to positive there. All right, and then last one, average rate of change simply means slope. I'm going to need 2 points. And remember, this is free response, so you don't have to simplify it down. Over your interval 1 to 4. Now, it's average rate of change of G prime. So I'm going to write it again. I know I already wrote it twice, but I'm going to write it again. It's 2e to the f of x, and then chain on f prime of x. So if we plug 1 into that, I feel like we already did that. F of 1, they told us was 5. Oh yeah, it's this right here. F of 1 is 5. And then when you chain on f prime of 1 is 3. And then 2 times 3 was 6. So 6e to the fifth. So we kind of already did that one. Now, if you plug in 4, you're going to get 2e to the power f of 4, which I'm going to come to that in a second, times f prime of 4. We don't have f of 4, and we actually do not have a way of getting it. This is not f of x. This is f prime of x, and the only f value they gave us is 1, not 4. So we actually don't have the ability to get that. Now you're like, Ms. Cole, they would not give us an undoable problem. Here's how it works. F prime of 4 is 0. This is f prime, and f prime of 4 is 0. So if this portion is 0, it doesn't matter that we can't find that because 0 times anything is just 0. So again, they will not give you an undoable problem. And then you just set up your slope. It doesn't matter how messy it looks. Please leave it alone. You can't do anything to that anyway. Really, I mean, the most you could do is 4 minus 1 is 3. Please just don't do anything. Just leave it like that since it's free response.